Hey, we are back at AP Review. This is 2011 Form B, BC free response number 4. The graph of the differentiable function y equals f of x with domain from 0 to 10 inclusive is shown in this figure that I drew terribly. Cool. The area of the region enclosed in the graph of f and the between the graph of f and the x-axis from 0 to 5 is 10, right? The area of the graph enclosed between 5 and 10 is 27. The arc length of the portion of the graph of f between 0 and 5, so from here to here, that curve, is 11. The arc length of the portion of the graph from 5 to 10 is 18. So this arc is 18. The function f has exactly 2 critical points. They are located at x equals 3. So at x equals 3, there's a horizontal tangent, and at x equals 8, there's a horizontal tangent. Great. Find the average value of f on the interval from 0 to 5. Okay, so that was an awful lot of words. Like, I opened this problem and was like, oh my gosh, there's a graph and so many words. So I already was stoked that I had to redraw a graph for you because we all know I'm awesome at that. And then also, it's a full paragraph of words. It's not awesome, but you have to take a deep breath and think, okay, I'm going to be asked to use each piece of this information at some point. I just have to go back and read carefully, and it's fine. The questions aren't super difficult. It's just daunting to open a problem and see a massive paragraph of words. Cool. Part A. So the way you find an average value of a function on any interval is you integrate the function over that interval and then divide by the width of the interval. So 1 over 5 minus 0 times the integral from 0 to 5 of f of x dx. Now, I was given that the area in this space of the curve is 10, but what I need to be aware of is that because it's below the x-axis, it's a negative 10. So this is going to be a 1/5 times a negative 10, and I'm going to get that it's a negative 2. Right, so that's my part A. Part B. Evaluate the integral from 0 to 10 of the quantity 3 f of x plus 2. Show the computations that lead to your answer. Okay, so part B. We are integrating from 0 to 10 of the quantity 3 f of x plus 2 with respect to x. So that's actually 2 separate integrals, right? It's easier to split it up and say this is 3 times the integral of f of x dx from 0 to 10 plus the integral from 0 to 10 of 2 dx. So this is from the graph I have, right? So we know from the graph that I'm given that this area is a negative 10, right, because below the axis, and that this area is a 27. I want to check and make sure. Yep, so this is a negative 10 and this is a 27, meaning that this is a 3 times a 27 minus a 10, right? A 27 plus a negative 10, right? But then this guy is going to be a 2x evaluated from 0 to 10, right? So what's going to happen is I'm going to get that this is a 3 times a 17, right? Which should be a 51, right? Plus, this is going to be a 20 minus a 0 because I plug in the top bound minus the bottom bound. So I get that my final answer is a 71. Cool. That's my part B. Part C. Let g of x be the integral from 5 to x of f of t dt. On what intervals, if any, is the graph of g both concave up and decreasing? Explain your answer. Okay. So, this is one of those ones where you want to make a math flowchart, right? So, we're asked to do 2 things. Okay, so first thing we're given is that g of x is the integral from 5 to x? Yeah, 5 to x of f of t dt, right? Now, they ask me about they ask me about concave up and decreasing. So I might as well bust out some derivatives now because I know I'm going to need them. Based on the second fundamental theorem of calculus, when I derive with respect to x, the derivative is going to cancel this integrand, and I'm just going to get f of x times the derivative of x, which is a 1, minus f of 5 times the derivative of 5, which is a 0. So I just get that g prime is f of x. That means my g double prime of x is f prime of x. So what I want you to notice here is that the relationship is that g prime is the y values on the graph, right? G prime is f, which is the y values on this graph, and g double prime is the slope of the given graph, right? Because f prime should be the slope of f, so the slope of the given graph. So now let's go ahead and make our flowchart. What they ask us is they want g to be concave up and, right, so I'm put the word both, they want g to be decreasing. So this is what I was asked. So now let's go ahead and translate that to the mathematical definition, right? So G being concave up, by definition, means that G double prime is greater than 0, right? G decreasing, by definition, means that G prime is less than 0, right? We're then going to translate that to what we can see with our eyeballs in this particular problem. And this is the sort of section of your flowchart that is going to give you the explanation you need to get those points for explaining your reasoning. So I look at the connection between G double prime and what I can see with my eyes. G double prime is the slope of the given graph. So what I want to say is that the given graph, right, is increasing. The other way to say that is has a positive slope, right? Either of those would be the same thing. So I'm looking for where the given graph is increasing, right? G prime is less than 0. Well, I know that G prime is really just the y values on the given graph. So what I'm going to see with my eyes, if G prime is the y values on the given graph, we want the y values on this graph to be less than 0. So the given graph, right? So the given graph, and the other way to say that is f, right? So if you want to be safe, say the given graph f is increasing, right? The given graph f is below the x-axis, right? That's what it would mean for f to be negative. It would be below the x-axis. So now what I'm looking for are two things. I'm looking for where the given graph is increasing, meaning going uphill. Well, that's happening on this entire window here. I kind of missed, but you get the gist, right? And I also want to know when, so that's that I did that in red, right? So I did this in red. And I also want when this given graph is below the x-axis. Well, that only happens here. So it seems to me that the only overlap of those two things, where both of those things are happening at the same time, is this window from 3 to 5. Now, since I want this thing to be strictly both of them, like not equal to 0, I want the open window from 3 to 5. I can either say 3 is less than x, which is less than 5, or I can say it in my favorite option, which is parenthetical 3, 5, parentheses on both sides because they are not included. All right, cool. Part D. The function h, ooh, we have a new function. Let me erase some stuff. They don't mention g at all, so I'm going to erase all this stuff about g. All right, cool. The function h is defined by h of x equals 2 times the quantity f of x over 2. So h of x, right, is a 2 times f of x over 2, right? This is part D. Okay. The derivative of h prime is f prime of x over 2. So they actually give you h prime. That was very nice of them. It's f prime of x over 2. We could have found that, but they gave it to us. Find the arc length of the graph of h from 0 to 20. Tricky. Okay, so what this is going to mean is that we have to know the formula for arc length. And this is why they gave you those numbers before. They mentioned that this curve has a length of, I believe it was 11, right? So this arc length is 11, and then this arc length from here to here was an 18, right? They gave us those earlier for that reason. Okay, so the arc length formula, so if I want the arc length, right, for h of x on the window from 0 to 20, right, then what I'm going to have to do, right, is I'm going to have to write that's the integral from 0 to 20 of the square root of 1 plus h prime of x, quantity squared, with respect to x, right? But we know that h prime is the same as f prime of x over 2, right? So this is the integral from 0 to 20 of the square root of 1 plus f prime of x over 2, quantity squared, with respect to x, right? Sorry, 0 to 20, not 0 to 2. Okay, well, the trick is that what's really happening here, right, is I can change this. So I'm going to say let u equal x over 2, right? So then du would be 1/2 dx, or I'd end up with a 2 du as my dx, okay? But these were x bounds, right? Those are x bounds. So if I change them to u's, I'm going to have to change the bounds. So my top bound, right, my top bound was x equals 20, but we know that u is x over 2, so I'm going to get u equals 10 as my top bound. And my bottom bound was x equals 0, and I know that if I do 0 over 2, my u is also going to be 0. So to point out what's happening here, if I look at this if I change this integral around, what this integral is going to look like if I put it in terms of u is this is the integral from 0 to 10 of a 2, because the 2 du, right? 2 root 1 plus f prime of u quantity squared with respect to u. Well, this is just double the arc length of this curve that we already have. So this is just double the 11 plus the 18, right? So that should be double of a 29, which is a 58. So that's my arc length. And that was a little bit tricky. You had to spot that 2u trick to get that it's a 58. I think most of us knew we'd be using the 11 and the 18. I think that if you don't see the variable change, if you don't change the x over 2 to a u, it's a little bit hard to see why it is the way it is. And you might be thinking, what do I do with that 20? Anyway, there you go.